Hey, what's happening, guys? Got something new to look at today. This is the Evive Starter Kit STEM do-it-yourself kit. And I saw a review of this on Kangaroo Dave's channel. And the guy that put this together, Abhishek, contacted me and said, would I like one to play around with and show you guys? So yes, I said I sure would, because what I saw on Dave's channel looked very cool for getting some younger kids interested in Arduinos and electronics and just STEM in general. So this is a nice big box here. It is well over a foot. Call that about 13 inches by 9 inches by 2.5 inches high. And if we open it up here, we get the letter with all the goodies and some links here telling you where to go with this, along with an enrollment key. This talks about the Evive here, the prototyping tool. And it gives you a little bit of information about what's going on with it, telling you about all the different things, all the different components that are included in it. We have the Young Maker's Guide. This is a heck of a book. We're looking at 89 pages, color glossy, very nice. I know that Dave had one complaint about it, and that was the electronics essentials doesn't consist of very much. It tells you voltage, current, resistance. It gives you the whole pipe analogy, and then goes right into analog digital signals, how to visualize them, and then into programming. So yeah, it is a little light on the basic electronics end of things, but that's okay. Now it says this is a 380 part kit. So we've got a little board here, very nice. And this is the heart of it here. This is the Evive, or Evive. I'm sorry if I'm saying it wrong. This is where the magic happens if you can manage to open it. Alright, now unless I'm mistaken here, this looks considerably different than what Dave had. What Dave had, I think, was an Arduino Mega in here. Now this board looks similar to a Mega, but they've definitely made some changes to it. As I popped off this cover, you see here, it tells you more pins are available and gives you a couple links as to where to go. You'll know if there's a battery in here or not. No battery installed, and you know, I really don't expect them to install a battery. Wow, it comes with an 18650. Holy cow. Pretty cool. So let's see if I can put some power to this. Alright, I've got a 5-volt lead here, and there is a V-in port here. Unfortunately, it does not tell me whether or not it's center hot. So this is always the exciting part. Yeah. Hey, how about that? She lights up. And it says I can use the joystick, which I believe is this. Okay, so we have controls, and how well you guys can see that. I'm gonna zoom in here a little bit better for you. Alright, so there we have it. I know it's kind of hard to see. The red on the black is not the brightest. Kind of like me. So we have controls, we have very sensitive. Sensing, mini oscilloscope, serial monitor, pin states, beta function generator, touch sensors, user defined, examples, exit firmware. Let's have a look here at the mini oscilloscope. Okay. Now I don't know anything about it, so you know, we're just then we have a serial monitor. Sure, 9600 sounds great. Clicking the thing takes us right back. Pin states, digital pin states. Very nice. This is very nice indeed. Beta function generator. Oh, okay. So we can generate a square wave, frequency, amplitude. Wow. Touch sensors. I don't know where the touch sensors are because I have not read the instructions, so we won't be sticking our fingers into any place right away. Then we come down here, we have examples. TFT display, probe vSense, TFT serial monitor. Let's see, TFT display, pot 1, analog value 0. Ah, looky there. So as I turn the pot from 0 to 1023, yes. Yes, indeed. What if I flip the switch in the opposite direction? Yeah, that's interesting. Doesn't quite return to 0, but you know, nothing in this world is perfect. So this thing in and of itself is very cool. Let's look further into the kit and see what all we get. Sorry we're not being able to see the whole box, but don't worry. We'll go through everything that is included here. So we have a little 4-way joystick, an ultrasonic sensor, IR sensor, a different type of IR sensor, and a Bluetooth module, the HC05. Very nice. This is a mount for the ultrasonic sensor that you can mount on the front of your little car here if you make the car. We have a little 9-gram servo, another one, 2 drive motors for the wheels for the car. Oh, that's a little unidirectional ball for the bottom of the car. These are the pincher gears to make a grabber on the front of the car. Couple of mounts there. We have some alligator clips, some 3mm LEDs, some electrolytic capacitors, trying to see what the values are. 100 microfarad, some tactile switches, lots of resistors, and some photo resistors, some LDRs. Lots of nice stuff there. In the center here we have some more laser cut acrylic parts. We have a couple of wheels. And we have our probes. This are the shiniest wires I think I've ever seen in my life, and they have a very unique aroma. Alright, we got some spacers, hardware, and then down here we have a little screwdriver, a lot of DuPont cables, zip ties, and a USB cord. Let's go and get the that little control panel thing. Open it up, have a look inside, put the battery in, see what we can do. Let's have a look inside and install the battery. Hopefully this is the right size. That'll work. Looks like 4 screws. It's a very nicely done case. Actually, that's a little small. Go one bigger here. That one doesn't want to come out. There we go. Anyway, I was saying it's a nicely done case. Very nice packing for the whole thing. High quality all around. Screw doesn't exactly come out straight there, so. Alright, going one bigger. To the PH1. That's a winner. And that one was in there super tight. None of the others are in there that tight. Okay, so now we can get a better look inside. Alright, here's a pretty close-up look at the insides over here. Now, I'm not going to do my usual try and guess components because people always give me shit about it. Yeah, I don't know every component just by looking at it, sorry. Not something that I needed to deal with in the past, so don't really know. Let's see. Can we pull this Mega off here? I don't want to use, as Big Clive would put it, unreasonable force. Alright, well, let's not do it because I don't want to break this. So, if we look over here, I know it's upside down, but you can see our two-way power switch, internal, off, external. Then we have some voltage sources here, 3.35 volts, variable, VSS. We have a V in here, USB, and a variable voltage control. Right there. We have our probe inputs, which are solid, very nice. And then here, on the bottom, hey, this light would make a lot more light if I turned it on. We have some more connectors. Okay, as we look here, we can see M1 and M2. These are going through an SN754410 IC for motor control. Then we have our servo outputs. Then we have these motor drivers here. We have a DAC, which is going through an MCP 7425. Then we have IO 3.3 volt going through a 74 LVC45. Then we have this graph one here So I'm not quite sure what that one's doing. Then we have our probe controls, which are also going through an ADE 7912. We looked at these controls here already, and there's nothing on that side. There is a SD card slot. So let's install the battery. Alright, here is our battery they've provided, which is a Samsung ICR 18650-26J. We have here intrinsic 3.7 volt 2600 milliamp hour battery pack, and it has a nice little connector here that'll only go on one way. I have some tweezers out here earlier. Yeah, who knows where they may have ended up. I'm just peeling off the sticky here. Now this is a keyed connector, so it will only go in one way. You don't really have to worry about blowing it up doing this part. We'll put our battery there onto the sticky pad and see if we can't put it all back together nice and neat. At least that's the goal. Hopefully everything bumps back together nice, right? It all lined up very well. There's no problem putting these screws back in. Again, the construction here is excellent. Looks like I need a little more screwing. Alright, so if I flip the switch to internal, yay! We get a power light, and our little monitor lights up. Very nice. Alright, let's power it up again and have a little play with the built-in oscilloscope. Alright, so we're going to go down to mini oscilloscope. And I'm going to zoom in here so you guys can see the scope. And I'm going to attach leads from my function generator here. One to the common and one to the voltage probe. Not really getting much there. Let's increase our amplitude of the signal. There's 5 volts peak to peak. Still not getting much. Let me play with this for a second. Okay, I had to slow my function generator down. We're looking at 60 hertz sine wave, 5 volt amplitude. You see we have 20 milliseconds per division, and by messing around with this little thing here, it's 50 milliseconds, 20 milliseconds, there's 10 milliseconds. Two volts per division, 1 volt per division, half a volt per division. There's 5 volts per division. Yeah, I'm just not getting whoops, exactly how this goes together. 5 volts per division. These don't seem to do anything. Neither do the buttons. Okay, let's change our wave shape. We'll go with square wave. Okay. Now let's change our frequency. There's 60 hertz. There's 100 hertz. Now it seems to have lost its mind. 2 volts, 10 volts. This is still 100 hertz square wave. If I turn it down, there's 50 hertz. Yeah, I'm not quite sure exactly what's going on with that there, but if I can swing that around to show you my function generator, you can see what I'm feeding it. You know, it's nothing spectacular, but it just doesn't seem to kind of know what to do with it. Let's try and restart it again. Yeah, 50 hertz. Alright, let's go back to wave. Go back to sine wave, 50 hertz sine wave. I don't know what's going on. Why it's not picking up my 50 hertz sine wave now. There we go. I guess if you switch between waves, well, let's try that. Let's go back to square wave. Square wave. Okay. Then I'll disconnect the probe and reconnect it. Yeah, it doesn't know what to do with a 50 hertz square wave. How about triangle wave? So yeah, not too much going on there. Let's try sensing, which I think should be like a little voltmeter. Okay. And I've got just a simple battery here. So we should get somewhere around 1.2 volts. 1.66 volts. Yeah, that's not too bad. So that kind of works, and that's a pretty neat little feature of this thing, that it works as a voltmeter and a very rudimentary oscilloscope. So I like that a lot. Let's open this up again. And you can see the mega and the stuff that's going on there with it. Now what I want to do is I'm going to bring this over here just a bit. Actually, I'll go this way. And we'll put this booklet here so that we get a better idea of what is going on. So this right here, you see we have an interface. Now let me switch it over so that I can get some light in there and you guys can see. Right there we have an interface for an XB or an ESP826612E on the outside there. We have 5 volt and ground here. Then we have our Arduino pins that are available all around. Now we have this jumper here. See that little jumper down there? that corresponds to right here, our probes. We can switch the jumper. Probe IV can be set for voltage sensing, plus minus 5 volts, or current sensing, plus minus 3 amps using JP2. So that's in current mode. And if we move that over there, or now it's in voltage mode, but if we move it there, it would be in current mode. And then if we look over here, we can see all of our different power points that are available on the side of the unit. So that is really nice. I think personally that this little device here is a great way to get started in STEM. So that's pretty cool on its own. If you could buy that on its own, I would recommend that. Now we have this book. Come up here so we can get as much of this into the camera as possible. We have introduction, blah, blah, blah. I'm just looking through here. Just telling us about some of the parts. We have graphical programming versus conventional programming. Fun with an LED. More about the graphical programming. Now here, see, it's showing you how you can wire up the joystick here to use it. So that's very nice. This is definitely, aimed at the younger generation. You can build yourself a little robot car. Now this comes with all these videos, and I'm not going to go into that. I am going to put a link down below to Kangaroo Dave's video on this, on the videos, so you can see what's going on with all the videos. There's no need to reinvent the wheel here. Now this is really nice. It's showing you how to recreate that little robot gripper. You see, you can put it here on the car. A little bit of information about the motors and the grippers. So Dan, this is very nice. If you've got a child that's interested in getting started with electronics and stuff, I think this would be a great way to get into it. Anyway, that's about all I'm going to say about it. I want to thank the folks at Stempedia for sending this to us. I mean, this is high quality stuff here. Now, I have no use for it here, but I'll tell you what I'm going to do. I am going to take it to the elementary school here in town, and I'm going to donate it to them and let them try and spark some interest in a young person's mind for electronics. So it will be going for something good. Alright, that being said, if you guys enjoyed this video, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. I'll put a link to the Kickstarter thing down below. Also a link to Kangaroo Dave's video on this. Big thanks again to Stempedia. Big thanks to you guys for watching. That's it. I'm out. Peace.